Hi, everyone, and welcome to our 2 o'clock session. Today, I'm going to show you something that we discussed yesterday. So why the 2D smile design has huge limitations, and we need to understand the limitations of 2D smile design. What do we need to know when we go and design a 3D case? And more than that, what are the limitations and what can we change to make it work, right? What can we change to make it work? So the 2D smile design, just as like a summary, was the concept of 2D smile design is from the 80s, drawing on pictures, the 90s, different computer softwares, Keynote, PowerPoint, and then different softwares, including, of course, all the apps that I have created, like the DSD app and the SmileFy. But with new technologies and with the new, my new research and my new development and the studies that I have done for the last couple of months, I just realized that there is no way that we can transform a 2D smile design into a 3D smile design because we have limitations. We need to understand the limitations. So we created new technologies to make it more accurate, to solve all the issues from the limitations of these smile design concepts. And as a summary, we do have, when we create the templates, we do have the perfect picture, the perfect position, and a certain occlusal size of the donator, right? So we create these beautiful shapes from Jan Haito's models. And these patients, they have certain characteristics. They have a occlusal size, arch, and every single tooth has a angulation to the front, a rotation to the front. And based on these characteristics, we created 2D outlines. Very simple to explain. As soon as we have a patient's picture, number one, the picture is different than the picture that we used to create the outlines. The rotation, tilt, patient's head position is different. That's the first problem. The second problem is that the arch size and the occlusal curve of the patient is different than this curve from Jan Haito. It means we cannot match the template that was, for example, created perfectly 90 degrees, 12 degrees to the front on a patient that has eventually a tilt head down 4 degrees, rotated to the side 2 degrees, and the arch size requires a rotation of the frontal tooth of 8 degrees or 7 or 15. Everything what is different than the original 12 degrees rotation from Jan Haito doesn't work. So we need to understand this limitation. And I told you yesterday, the 3D smile frame that I have created is a new technology, and the big advantage is that the technology follows the face, right? The technology follows the face, so it is much more accurate to follow the face, to instead of 2D outlines to use 3D veneers, and then to always have the perfect visualization of the certain template in the frontal position. The whole 2D design, 3D translation is so inaccurate, and it makes lab technicians very, they put them in a very, very complicated situation that we need to act, and we need to change and to help with technology to create a much more accurate result. And that's innovation. That's the way, you know, everything evolves in every single area of technology. We do have technologies, we do have innovation, and now we need the mindset shift to go and to understand how should we use new technologies to achieve more predictability and accuracy when it comes to smile design. So I'm going to show you real life examples. Okay, so let's go with an example that I have prepared for us that looks like a canine, right? And that's the 3D outline of a canine. The 3D outline of a canine, and we can say, okay, that's the 90 degrees view to this canine, and we need the rotation. So we could create, for example, this outline, and we can design using this outline a canine in the right rotation. That's not working. Why it's not working, and why we use shells veneers for this kind of design. Because as soon as you start rotating, you realize that the surface of the tooth is super complex. It's not a 2D plane. It's not a 2D outline that can be drawn on a plane, on a surface, on a plane surface, because the surface of every single tooth is super complex. Let me show you what I mean. So I start turning the canine around because we need, let's say, 40 degrees. And that's the outline that I get from this very canine, because that's the surface of the canine. Anything else is wrong. It's completely wrong. So even the rotation of a tooth cannot be represented with a 2D outline. It's super complex. The distal line, you see, it's very, very complex. So there is no way we can represent with a 2D outline this complex surface of a tooth. Even with the outline, we don't have any reference. Even if we would make this outline work somehow, right? Like this. We miss the information of the surface. So we see an outline, but we miss the information of the surface of the tooth. And this information is super important. We cannot just ignore in our smile design procedure the information of the surface, the topology of the tooth, right? Because this certain topology, we do have, you see, we do have a very complex structure. This tooth, for example, we see the structure of the surface that's different than, for example, this canine, right? It's different than this canine. So how should we make the decision and show to the patient a proposal of a smile design when we have, number one, the huge difference between the outlines of a 2D outline and the real rotation of the 3D template, plus we miss the information of the surface, the details of every single tooth. Because if I have an outline and that's one proposal of a canine, and that's the second proposal of the canine, these two canines are completely different. Also this one, right? So missing this information is also something that we need to solve. And the only way that we can solve all these issues is to just stop using the 2D designs besides motivational and besides gingivectomy cases where we don't change the shape. We just adjust the 2D shapes, as I showed yesterday, to the patient shapes, and we just design gingivectomies, right? Purely motivational, it's okay. We go into detail, we change the technology, and we go and explain exactly the 3D design. So that would be the most accurate and fair way to explain to the patient, we do have a design, it's motivational, we can create some aesthetic plan, but then we need to use different technologies to create a real accurate output. And with the new feature that we're gonna have, the smile simulation with the veneers, we're gonna have the most accurate smile planning simulation that you can have, because instead of outlines, every single tooth is a veneer, and due to rotation, we follow the face and we get the perfect visualization and representation of this very template. So let me go to my app and show you this case. So here we go. We do have the case, and I'm gonna show you 4 views. What I did is I created a 2D smile simulation. I took the outlines from, I took a screenshot from the outlines and the face. Just let me reduce a little bit here the sizes so that we have, okay. And that's my plan, right? That's my plan. That's my smile design plan. Let's see if I can do a 3D. That's my 3D. And as you can see in the occlusal view, the canine is a little bit corrected. The centrals are placed properly. So in the occlusal view, everything is correct. Maybe I go a little bit more distal and mesial so that I don't intersect with my central. Here a little bit adjustment on the occlusal rotation. This design, the teeth are placed correctly. The occlusal view, the teeth are placed correctly. How should we now adjust the design to the 2D outlines? It's impossible, right? It's impossible. So let me, for example, let me take the lateral, and I'm gonna bring the lateral to a position that looks like the outline. As you can see, it's not easy and not very clear how to do this, because everything what we have is very in the 3D planning is very complex as a visualization of the object in space. It's very complex. It's not, you cannot just take a 2D line and make it work. So it's more or less the same position right now, but just imagine if you take a tooth in 2D design, right? What you can do is just to turn the tooth like this and size. If you rotate the tooth clockwise or counterclockwise, your outline just rotates. But you cannot turn the 3D template clockwise and just get the same position as you think you have in 2D, because your lateral is rotated to the side. It means when your tooth is rotated to the side and you want to rotate the tooth clock or counterclockwise, the outline, the visual part of the tooth changes completely different, because it's a 3D object and you have many parameters like rotation to the front, clockwise, counterclockwise, rotation to the front, and tilt. So you have 3 different rotations that you need to perform, and your 2D design, it's just 1 rotation. And the outline stays the same, which in 3D doesn't, right? So let's go back to the 3D outline and to the 3D design. So for example, if I rotate my tooth like this, or like this, I don't consider this rotation. It's the horizontal rotation, right? Plus the tilt to the front or to the back. So it is not even near a way to superimpose this 2D design to the 3D design. It is a very, very visual, very far visual reference of something that you should try to match. Let's see what about the canine. So let's go, and I'm gonna here we have the canine. I'm gonna reduce a little bit the opacity of the canine so that we can. Okay, so we do have the canine. I'm gonna bring the canine perfectly and match perfectly with my outline. It's a little bit more like this or like this, and a little bit. Okay, let me see, maybe this too. Yeah, so now I'm close, right? I'm close. Let's see what's happened in the close the view and in the free view. I bring it eventually more out, more buckle. And let's see, where is my outline? So you see the visual, right? The visual surface that we see in the design use so many parameters: rotation, tilt, rotation to the front, doesn't match the 2D outline at all. And that's the big limitation. That's the big limitation. In case we have, for example, the canine, let me like this. And in case my patient needs a canine rotation that is close to the original template. Because if I need to turn the canine more, like that would be the rotation of the canine, so that it matches perfectly the outline. I can see like this. Okay, occlusal. You see the position is completely shifted. If I correct now the position of my canine and make it work here on in the occlusal view, like this. That's what I get. All right, that's what I get. And the biggest problem with the rotation or position of the teeth is the embrasures. The embrasures change completely based on the rotation to the front. So you cannot have any analysis of the embrasures besides I want them square or round, right? Square or round. That's the only thing that you can decide from a 2D design perspective. But as soon as you need to bring the design in 3D, there is no way you can adjust the embrasures with the 2D outlines, because as soon as you start adjusting the rotation of your tooth accordingly to the situation and to the design and you know, everything what you need to design, the outline goes out of the outlines go out of the tooth. The more the teeth are rotated, right? So the centrals they have a very small shift. The laterals bigger, the canines much more. So the bigger the difference is between the original rotation of the 2D template and the 3D template, the needed 3D template for the design, it's completely shifted, and it's impossible to create something that is accurate, right? So, and I mean, dentistry is not something that when we plan, we don't make it work somehow close to the plan. We want to plan as accurate as possible, as beautiful as possible, as accurate, as precise as possible. That's why we have to do the research. We have to have the discussion. We have to see what's working, what is not working, and we need to change it. We need to change the technology. We need to change the workflows. We need to change everything that is needed to increase predictability. Smile curve, gingival line, gingival curve. Everything displayed in 3D, in a 3D smile frame. Instead of outlines, we do have the veneers. No matter how I need to turn this tooth, I'm gonna get always the perfect visualization of this tooth. So let me go back to my here, and I'm gonna bring a new object. Let me see, templates. Yes. Okay, so that's my central from F8. Let me bring eventually the canine. Yeah, the canine. Okay, so that's the lateral. Okay, that's the lateral from F8. Now, if you take a look at the outline, right, that's perfectly frontal. If you take a look at you see the surface, right, and how the surface changes, and how this curve, right, look at this embrasure here, and now I turn. You see this circle changed completely from here to here. That's the outline of my lateral. So If I turn the lateral back, I do have a complete different outline. Which shows me that I cannot use a fixed outline based on some templates from the lateral and use this outline to design, for example, a plan for 3D. Because every single patient needs a different rotation. Based on this rotation, the outline from the actual template changes. That's why using, I'm gonna import documents. I'm gonna import, let me see, where are my shells? I think here. I do have shells somewhere, just a second. I need to find the folder. Here. Okay, let's go with 5. Okay, D5. No. I don't find right now my shells, the veneers, but they, what I wanted to show you is that having an option to design the simulation, right, like this, no matter what rotation we need for this patient, the representation of the tooth is going to be always correct. Plus, we see the structure of the surface, which is also super important, right? So we have all these details that we don't have in to the outline. Predictability, as precise as possible, and we need to use the technology and the innovation to make it happen. If we go and change our mindset to the 3D smile frame, right? The 3D smile frame. This 3D smile frame follows the face. This 3D smile frame follows whatever we have in the right position in the position of the head of the patient. It doesn't matter if the patient is a little bit tilted to the ground or rotated with the face, because that's the biggest problem, the picture. We follow with the 3D smile frame, we follow the face. When we follow the face, we always create the correct representation of the smile. If we do have an occlusal picture, or if we do have the occlusal picture or the intraoral scan, of course, what we can do is exactly like this. We define the occlusal curve and we set the size of the teeth, and then we generate the smile simulation exactly the same way we generate it in 2D. It takes 1 minute, but when the smile is created, we do have the most accurate representation of the template that we have used. If it's F8 from Jan Haito, it is F8 from Jan Haito, and this F8 from Jan Haito is represented. That's Juan Carlos Palma, these templates. But these templates are the representation of this of the templates, considering tilt, rotation, field of view in the frontal view, right? So now we have all the details that we need. We have the correct representation of the embrasures. we have the correct representations of the gingival margins and embrasures. We have the correct representation of the surface of the tooth. We have the correct representation of the tilt, rotation, and so on. And from here we go and we adjust our design. Based on the occlusal curve, we get the 3D smile frame, and in the 3D smile frame, these templates, these teeth are already calculated and accurate in place. That's the conclusion. Accuracy, analyzing what's not working in old smile design workflows, changing them, bringing new technology that allows us to create quick, the best user experience and precise plan for our patients. So as you see, the innovation mindset of SmileFy, our company, is the basis for everything what we do. And we're gonna analyze everything, every single issue in every single digital workflow, and we're gonna find solutions, and we're gonna improve everything what needs to be improved. These are my final words. And Carmina, are you here? Ah, okay.
I am. Not your final words, I hope. Tomorrow.
Yeah, final words for the today's session. Yeah.
Okay.
Done.
Thank you. Thank you very much, Ralph. And thank you all for being here. Before you go, I would like to give you more information about our events and what we can offer. So let me just share my screen right here. Currently, we offer our Smile Designer certification course, which will teach you everything you need to know about the app. So what Ralph showed you today is about our technology, how to use it in your daily workflow. And in our course, you can do it online, or you can do the in-person course. We have different dates, as you can see. The first one, it's on June 18th for the online course. And then on August 5th to 7th, it's a 3-day course for the in-person in Miami. Now, to give you more information, you will learn tips and tricks from our expert instructors. We'll focus on teaching the basic of the digital dentistry and the smile design principles, with, of course, providing you applications for larger cases and more complex treatment. So to give you, for example, more information on our online course and how it works, this is our most comprehensive course. It's a 4-week program, and after this, you'll get the certification with 21 CE credits, okay? And the way it works, it's basically, you will be able to learn everything from 2D to 3D design. Every Monday, we have a new module released with a total of 3 modules. Let me see right here. This is the first module about digital patient and smile design. The second module will be on the 3D smile design and the 3D digital mockups, how to create them, while the final module is going to be on the clinical tips and approaches. Every week we have also the Q&A sessions with our instructor, and every week you'll have to complete an assignment basically based on that module, okay, that we release. So it's very simple, but at the same time, very interactive, and you will enjoy it. You will learn a lot about our online course. Or if you prefer to see us in person, then come to our in-person course. It's basically the same topics, but it's a 3 days course. It's a hands-on course where you will learn basically every step of the process. If you want to know more about our courses, or if you have any questions, you can always connect with us. Our phone number is right here on top, and our email address is info@smilefy.com. Please do not hesitate to contact us. We will provide you all the information that you need, and I hope to see you soon. Thank you very much. Thank you for staying with us until the end, and I hope you have a wonderful afternoon.